Hello everyone, hope all of you are doing great. And in today's video, we're going to discuss the questions in the workbook, lesson 1.1, irrational numbers. You are supposed to remember, this is not the first thing that you're supposed to be doing. The first thing that you're supposed to do before doing this homework or before watching this video, study from the notes book. Done, mister? Then do the homework and mark it. Correct it using the answer key, the marks key. Done, mister. Then, after marking it, definitely you're going to come across questions that you do not understand why they are wrong or that you didn't even understand how to answer. Then watch this video to help you with questions you're struggling with. All right, let's start. First, remove this. Here you go. All right. The first question here says, copy this table. We don't need to copy it. You just need to answer. Rational or irrational? So, assuming that you studied the notes before doing the homework and you did the homework and you marked it, and now you're watching this video to help you with questions you're struggling with. Here, square root of 36, I can find an answer to it. It is 6. So, definitely rational. Square root of 48, I cannot find an answer to it. It's a third, irrational. Square root of 64, it is a perfect truth. It's 8 times 8, so it's just 8. Rational. Square root of 84, imperfect truth. I cannot find an answer to it. Irrational. Cubic root of 100, I cannot find an answer to it because actually, don't you know that square root of 100 is 10? Yes. But cubic root of 100? No, mister, it is a third. I know that cubic root of 1000 is 10, but cubic root of 100 is a third. Good. So now cubic root of 100 is a third, which is irrational. Let's move on to the next question. Question 2. Look at these numbers. Write the irrational numbers. Well, irrational number, mister, 12.77, that's a terminating decimal. It ended, so it is rational. Negative 36, integer, rational. Square root of 27, oh, that's a third, irrational. Square root of 500, I cannot find an answer to it, mister. It's a third, irrational. 61 over 12, a fraction, mister. Any rational number is a number that can be written as a fraction. They're giving me a fraction, definitely, mister. It's rational. Cubic root of 8, negative. Cubic root of 8, yes, mister, it is rational. Why? Because it's negative. Cubic root of 8 is 2. It's negative 2. I can find an answer to it. It's not a third. So the only two numbers that are irrational numbers is square root of 27, square root of 500. Write the integers, everything else. Well, the integers, they don't want you here rational, so don't say it's everything else like what I was going to say right now. Integers are only whole numbers, negative, positive, and 0. So here, negative 36 is the integer. Cubic root negative cubic root of 8 is an integer because actually it's negative 2, and that is it. All right. Here, question 3 says to you, write whether each of these numbers is an integer or a third. This is an integer. It's a 5 integer. This is, no, mister, I cannot find an answer to it. It's a third. This is, I cannot find an answer to it. Mister, is square root, not cubic root. Look at this. Square root of 125 is a third, but cubic root of 125 is an integer. Square root of 225 is 15, mister, so it is an integer. Cubic root of 225, I cannot find an answer to it, mister. So it is what? It's a third. All right, mister, am I supposed to know the square roots and the cubic roots till big numbers? At least the 12, until like from square root of 1, square root of 4, until you reach square root of 144. These are the squared numbers. You should know the squared numbers. 1, 4, 9, 16, until you reach 144. If you Google them, you're gonna find them all there. If you need help with that, you can even text me. Cubic numbers, you're gonna find. I need you until the 10th. So you're gonna find until cubic number of, from cubic number of 1, cubic number of 8, cubic number of 27 until you reach a cubic number of 1000. All right, so let's continue. Now, square root of 3 plus square root of 6. They want you here to write if it is rational or irrational. Good. All right. This is rational or irrational? Mister, it is irrational. Why? Because I have square root of 3, which is a third. Here, square root of 3 plus 6. Is it rational or irrational? It is rational, mister. Why? Because it's square root of 9. Square root of 3 plus 6 under the same root. It is square root of 9, which is just 3, positive or negative 3. Here, is it an integer or irrational? Rational or irrational? Mister, square root of 64 is 8 plus cubic root of 64 is 4. So yes, it is rational because it is actually equal to 12. Cubic root of 8 plus cubic root of 19. Mister, this is 2 plus cubic root of 19. I cannot do it. So, mister, it is irrational. Why? Because cubic root of 19 is a third. Good. Next. Find 1.5 squared. If you do 15 times 15, 1.5 is 1 times 1.5. We agreed before, if you want to multiply decimals, ignore the decimal point. So 15 times 15, which is 225. But I have two decimal places. Here is one, here is another. So I want two decimal places, 2.25. So 1.5 squared is equal to 2.25. All right, good. Show that square root of 2.25 is a rational number. I've just done it. Square root of 2.25 is actually the same as 1.5. Yes, 1.5 times 1.5 will give me the 2.25. So that's why it is rational. All right, is this root of 20.25 a rational number? Give a reason for your answer. You're going to need to use the calculator for this, and you're going to find that square root of 20.25 is going to give you, let's use the calculator for that. Here, let's say root of 20, definitely have a scientific calculator, 4.5. So the first one is 4.5. Yes, it is rational. And in the last one over here, you're going to find that it is 1.1. So this one here is 1.1. Let me close the calculator. So this, yes, it is rational. And the square root of 20.25, we found that it is 4.5. And here also, yes, you're going to find that cubic root of 1.331 is equal to 1.1, so it is rational. All right, here, the next question, question 6. Let's do it here. Question 6 says to you, without using a calculator, show that. So they want you to show this without using a calculator. All right, mister, it's very easy. The only thing that I'm supposed to do is cube root of what is 3? The 3 is cube root of what? Because here they're using cubic root of 41. I need to show that it's between 3 and 4. Then I need to convert the 3 and 4 into cubic roots as well to show that this is true. So cubic root of 27, cubic root of 64. Oh, yes, mister, it is between. Thank you. Here, mister, cubic root of 800. To show that it's between 9 and 10, I need to convert this 9 into a cubic root and this 10 into also cubic root. You're going to find 9 times 9 times 9, 729. 10 times 10 times 10, we agreed you need to memorize these cubic roots until the 10th. It is cubic root of 1000. So yes, mister, cubic root of 800 is between cubic root of 729 and cubic root of 1000, so it is true. Same thing exactly over here. They want you to show that square root of 1.36 is between these two numbers. So I'm going to do the same thing. I need also here a root. I need also here a square root. So it is 1.1 times 1.1. Well, Mr. Ignore the decimal point. It's just 11 times 11, 121. And I will have two decimal places because this means 1.1 times 1.1, two decimal places. So 1.21 here, 1.2 times 1.2 is 144, Mr. 12 times 12, 144. And I have two decimal places as well. So it is 1.44. Yes, Mr. 1.36 is between, the root of 1.36 is between the roots of 1.21 and 1.44. Let's get back to the book. It says to you here, without using a calculator, find an irrational number between this. How can I do this, Mister? Everything is explained to you in the notes. Between 2 and 3. Let's use this space. This empty space over here. All right. An irrational number between 2 and 3. I'm gonna get the 2 is what as a square root? Mister, 2 is square root of 4. And 3 is what as a square root? Square root of 9. Anything in between is going to be irrational. So, Mister, if I write here square root of 5, correct. It's a third. Square root of 6, correct. Square root of 7, correct. Square root of 8, correct. All right. Another person might have said to me, Mister, if I change them into cubic roots, like I say the 2 is cubic root of 8, and the 3 is cubic root of 27. Also correct. Anything in between is going to be a third and can be considered a correct answer, starting from cubic root of 9 till cubic root of 26. Everything in between is a third. All right, same thing exactly with question B and the question C. Question B, 6 and 7. All right, no problem. I'm going to convert this into square root, root of 36, and this root of 49. Anything in between is a correct answer. Same thing with 1.4 and 1.5. 1.4 times 1.4, it's as if you're saying 14 times 14. And here, as if you're saying 15 times 15. Let's erase this. All right, so 1.4 times 1.4, it's 14 times 14. Definitely you can do it quickly. You can do it mentally, or you can do it on the calculator. Sorry. 14 times 14, 196. So square root of 196, and here 1.5, but definitely I need two decimal places because 1.4 times 1.4 is going to be 1.96. And here, square root of 2.25. Good? All right. So now anything in between is going to be irrational. What is a third between 1.96 and 2.25? Anything in between. Someone might say to me, square root of 2, Mr. Correct. It is between 1.96 and 2.25. Square root of 1.96. Correct. Square root of until square root of 2.24. Correct. That's 2.24. It's in between. So that's any third in between square root of 1.96, which comes from 14 by 1.4 by 1.4, and the between root of 2.25, which comes from 1.5 times 1.5. All right, next, without using a calculator, estimate root of 140 to the nearest integer. Mister, to estimate the root of 140, I need to find the perfect root before it, the perfect root after it. All right, so square root of 140. What is the perfect root before it? If you know the perfect roots, all of them until the 12th, you're going to know that before it, the perfect root is 121, which is equal to 11. After it is root of 144, which is equal to 12. But they want me to estimate a mystery. Then I need to find which one is it closer to. Is it closer to root of 121 or closer to root of 144? It's closer to root of 144, Mr., which is 12. So estimating this is 12. That's to the nearest integer. You are not allowed to say to me, Mr., it is 12 point something, or it is 11.8 or 11.9. Wrong. They want an integer, so it is just 12. All right, now with cubic root of 350, we're going to do the same thing exactly. What is the cubic root that is before cubic root of 350, the perfect cubic root. Yes, if you know already the list of cubic roots as we agreed, you're going to find that it's cubic root of 343, which is actually 7. And the perfect cubic root that is after it, if you know them very well, you should know that it's 512, a cubic root of 512, which is 8. If you don't know it, you just should do 8 times 8 times 8, which is cubic root of 512. Which one is it closer to? Clearly, it is closer to a Mr. cubic root of 343, which is just a 7. All right, next. The thing that you hear Aaron says, my calculator shows 2 and 7 over 81 is the same as this. And this does not have a repeating pattern. So 2 and 7 over 81 is irrational. Unfortunately, Aaron is not correct. No, he is not correct. Why? For two reasons. You should mention the first reason is 2 and 7 over 81 can be written as a fraction. It is already a fraction. So it is definitely rational. The other reason is the decimal that is provided. Yes, it's not repeating, but it ended. It's not endless. It ended, mister. I don't have these 3 dots at the end. So it ended. So this is a terminating decimal. So definitely it is rational. So if you depend on the fraction itself, I can write it as a fraction. It's a mixed number, mister. Mixed number, it can be converted into improper fraction. It is a type of fraction. So it is a fraction, so definitely rational. It has terminating decimal, so it's definitely rational. All right. Do you think that 2 and 7 over 81, the root of it, is a rational number? Give a reason for your answer. Well, if you convert this into an improper fraction, 81 times 2 is going to give you 162 plus 7 is 169. I'm converting it into an improper fraction. 81 times 2 plus 9 plus 7 is 169. Over 81 remains the same. The root of it, oh, yes, 169, the root of it, even if you use the calculator, it's 13 over the root of 81 is 9. It can be written as a fraction, mister. Yes, it is rational. All right, next. Use a calculator to show that this is a rational number without using a calculator. Square root of 2 times the square root of 32 is equal to square root of 64, which is 8. It is rational. All right, find the two irrational numbers with a product. A product, we agreed, means multiplication. So two irrational numbers with a product of 6. Mister, for the 6, I'm going to take it here. For the 6, I can write root of 2 times the square root of what? 18, which will give me square root of 36, which is 6. So the two irrational numbers that give me a product of 6 is root of 2 and root of 18. For the 9, mister, is there another possible answer? Yes, there is another answer for this. For the 6, what is the other answer that you can get? It's root of 3 times root of 12 gives you also root of 36, which is a 6. So that's about the 6. What about the 9? Well, the 9, you can get it from square root of what? I want 9 أصلا يا mister. 9 is square root of 81. I already know this. So I want to break square root of 81 into two irrational numbers. So 9 is square root of 81. What are the two irrational numbers that give me when I multiply them? They give me square root of 81. Well, I can say square root of 27 times square root of 3. Because 27 times 3, we know that it is 81. So square root of 27 is irrational. Square root of 3 is irrational. That's it? Yes, that's it. All right. 10. I need two irrational numbers that give me 10. Mister, I know that 10 is actually square root of 100. I can break this down into 2/3 multiplied by each other. I can say root of 50 times root of 2. Yes. Are there any other possible answers? You might keep thinking about this, but I guess no. Because you're going to find 4 times 25, both of them are rational. You're going to find that 100 times 1, both of them are rational. That's it. So square root of 50 times square root of 2. Oh, somebody might think this way. Yes, there's another one. Square root of 20 times square root of 5. It will give me square root of 100, which is equal to 10. All right. Explain why, let's remove this. Explain why 5 plus square root of 2 is an irrational number. They're giving you a tip here to write it as decimal. To write this as a decimal, you need to use the calculator, and you're going to find that root of 2 is actually equal to, the root of 2 is equal to 1.414. So, mister, this is 1.1421, and it's 5 plus. Definitely, it's endless. So you have to say that this is equal because it is equal to 6.41421 and the three dots, which show that it is non-terminating. That's why it is irrational. Or you can simply say, if it comes to you in people one, you can simply say because square root of 2 is a third, which is irrational, added to the 5. All right, next. They are telling you explain, no, the next one, find the two irrational numbers with a sum of 5. In the notes, explain the last question in the notes. A sum of 5, okay, Mr. Ray agreed, is 5 plus any third that you choose. Any third, yes, any third. So it is 5 plus root of, let's say, 2. That's the first number. All right, that's the first number. The second number, cancel the third. Negative square root of 2 is the second number. All right, good. Let's move to C. Explain why it is impossible to find two rational numbers with a sum of square root of 5 because rational plus rational will always give me rational. Same thing also in D. Is it possible to find the two rational numbers with a product of square root of 5? No. Why? Because rational, write it, times rational equals definitely always rational. But write this in words, explain in words. Don't write it this way, like me. All right. So, next question. This Venn diagram shows all the numbers from a numbered line. A is the set of integers. So A is integers. B is rational numbers. Copy the diagram. All right, 25. Is 25 integer or not? Yes, mister, it's an integer. So you put it in the circle. Oh, but mister, it is also rational. Exactly. That's why integers, all of them are rational. All integers are rational. That's why 25 is in the integer circle and the rational circle. But you cannot get it out of the integer circle. So 25 is an integer. 5.5, no, it is not an integer. Integer is only whole numbers. So you write it over here because it is rational. 5 and 5 are 19. It's not integer, mister. I must write it in the rational. Square root of 25, that's 5. So you write square root of 25 here. It is an integer equal to 5. Cubic root of 25, cubic root of 25, mister, is actually not an integer, not rational. It is a third. So you must write it out of the whole thing. Cubic root of 25. Question 13. If n is 20, find the value of this. All what you need to do is just to use the calculator. You're going to find that square root of 20. Let's open the calculator here. Square root of 20 is 4.472 and a lot of other numbers. 4.472. So let's try this. 4.472. So let's say here 4.472, three dots, plus 2. What is going to be? This is going to be 6. So the first one is 6.472, the three dots. All right, here, same thing. Oh, mister, we agreed. Square root of 20 is 4.472 minus 2. So it's going to be, mister, 2.472, three dots. It's endless. So that's it. All right, the next one here. The next one, let's just agree on one thing. If you have two pairs of brackets multiplied by each other with only the sign that is different. And here I have square root of n, with here square root of n. Here is 2, here is 2. And only the signs are different. Only in this case, you can just multiply this by this and multiply this by this. That's it. So let's do it. Square root of 20, they said n is 20, times square root of 20, mister, any root multiplied by itself will give me the number that is under the root. It's equal to 20. Good. So square root of 20 times square root of 20 is 20 plus positive 2 times negative 2. What is positive 2 times negative 2? Negative 4 equals 16. That's it. Okay, so this one is 16. All right, next one here. If n is an integer, then square root of n plus 2 times the square root of n minus 2 is also an integer. We've just done it right now. Yes, it was what here? When we tried, look at this. When we tried here, n as an integer, it was 20. When we used n as 20, was the answer an integer? Yes, the answer is always an integer. Is Sophia correct? Yes, she is correct. Correct. Give some evidence. What's the evidence that they wanted? They want an example like this. You put square root of, let's put a square root of 4. For example, square root of 4 plus 2 times square root of 4 minus 2. Square root of 4 is what? Is going to be 2 plus 2 is 4 times square root of 4 is what? 2 minus 2 is 0. Well, it gave me here 0, mister. This is just our luck. It gives us 0 over here. It is still an integer. All right, even if you choose another number, square root of 9. Square root of 9. So it's 3 plus 2, which is 5. 3 minus 2, which is 1. So it is 5 times 1, which is 5. So will always give me an integer? Yes, it will always give you an integer. That's it. Thank you so much and see you in another video.